Good afternoon, everybody. Welcome. We are going to code some Elixir and hopefully have time for some Rust today. I'm going to go for about 2 hours, I think. And if you have any questions, as always, please pop them in the chat. The chat is like directly under my camera, so if you see me looking at the camera, or roughly in the direction of the camera, I'm probably looking at the chat. Please feel free to drop any questions or comments in there. I'd love to talk with you. Last time we had a double length stream. We had my friend Quinn Wilton on, who blazed through an implementation of Datalog and Rust with us. So today, my focus is going to be wrapping up the things we left dangling on Hardhat. And then what we will do is hopefully have enough time to look at that data log in Rust again, because I found that was really, really fun. And hopefully it'll wrap up in just about 2 hours. And y'all can't see on camera, but I am joined by my cat Bianca today. She has been a bit lonely today because she's in this room by herself, and so she's hanging out on my desk. And I'm not usually hanging out in the office on the weekend except for this. So, all right. Let's get started. Let's see. All right. If anything doesn't look right, just let me know. And otherwise, let's get going. Okay, so where we left it last weekend, we had committed the retry middleware. And we started adding Regulator, which is an adaptive concurrency thing. So it, rather than having this sort of hard limits like Fuse does for circuit breaking, Regulator will adapt to the changing conditions. So it's a bit more flexible, and also it requires fewer knobs to tune. Fuse is very much a break glass in case of emergency type thing, whereas Regulator will find the limits of your system, and when things start going badly, back off to the point where you won't be overloading things and making things worse. So we had retries, and then we have uncommitted quite a bit of code. So let's look at what is uncommitted, and Bianca is kind of in my way. All right, so we did some changes here, and I think what I did here, I don't recall exactly, but I was adding Regulator as the strategy on Hardhat Builder in the default module, so that we see that it injects the right middleware. And then in the macro, we were detecting this is the first time we used options on this use macro. So we're detecting which strategy was being used and defaulting to Fuse. And then if it's one of those two, then we use that. Otherwise, we raise this invalid strategy, right? And then we stuffed that atom into this strategy module attribute on the module. And of course, we added the callbacks that we expect for our Regulator middleware. Should regulate is one of them. Regulator ops is the other. And then in the before compile, we chose which circuit breaker to use. So maybe we need to change the name of that. But in the case where it was Fuse, so again, we're getting that strategy module attribute that we put up there, up here in the builder. We're extracting that in the before compile to see which one was chosen. And then we're quoting a little bit of a bit that we will inject into the final quote down below. So this is a pretty typical thing when you write macros in Elixir, is that you'll take smaller pieces based on what kind of code you want to generate. You just make quotes of those, and those become values that you can pass around. Um, and then um, and then when you want to include it in the final piece of code, you can either use I think there's a thing in macro that lets you chain different sets of quotes together. But in here, we were already going to have another quote, so we unquote that. So this is like unquote makes a hole in your macro that you fill in with whatever is in there, and that thing needs to be syntax tree. So the degenerate versions of syntax tree in some cases are simple types like atoms, but in our case it's a whole code block, and so we're injecting that right there where we were putting fuse before. Okay, and then we added documentation for the regulator options, and I think we just took the defaults that are in regulator, and then this should regulate callback, which takes this mod and it returns a function. This mod should be the module, excuse me, that we are injecting the builder macro into. Okay. And then we did basically the same stuff as we did on should melt for fuse. On errors, we regulate, and then when particular statuses are present, then we regulate those. Okay. We added regulator to the depths, and I want to see if we had written any tests. I'm not sure. Okay, so it's pretty clear we didn't write any tests. So let's get to that, and then we can wrap up this and probably consider writing some documentation. Now, what I'm going to do here is I'm going to, because I'm pretty sure what we did last time is we checked the output of this, that it would, our macro options would work. So I'm going to remove this, and we'll use, so you can see the Z thinks it's not changed anymore. And what we'll do in our test, yeah, so whoops, let's make a new file, and this will be regulator test. Okay. I just realized I didn't write up an agenda for today. So we will just wing it, and maybe I'll write it up at the end. Test. Okay, so we'll use XUnit case. And I'm not sure whether we can do async true or not here, so let's do false just for safety's sake. And then we're going to grab this stuff. Okay. And let's define our test client module. Use Hardhat. Strategy is going to be regulator. Okay, and now we need to do similar to this, the retry options. We need to check that when we select regulator as the strategy, we're going to get that middleware inserted into our default stack. So let's just copy that, and we'll say regulator options. Let's see. Let's describe strategy. Let's say describe strategy. Failure detector strategy. And we'll kind of, yeah, let's just reword this. uses hardhat.middleware.regulator instead of fuse. Okay. So what we're going to expect here is hardhat.middleware.regulator. And then we'll do that here too. Okay, so, and then we need to guess what the defaults are. So we could do something like, we'll do a couple things here. We're gonna fetch from those options. We're gonna fetch should regulate, and we're gonna say that that's equal to hardhat dot, or no, that's gonna be test client should regulate, and then I think that should work. No, I think the editor tried to should regulate /1 with no parens. Oh, that's not good. Okay. So the other thing that we should do is check one of the defaults that we use. So like, I don't know, back off ratio 0.9. 9 keyword fetch. Let's use double equal there. We don't need a pattern match that. Let's do double equal. Okay, keyword fetch ops back off ratio. Yep. Okay. And why are you reformatting that? That's incorrect. You put parens around that. Okay, that's kind of weird. It's weird that it would try to do that. All right, let's run this test. Okay, no failures. We can remove this fuse thing. Okay. Now there's a question in my mind about whether we should test regulators' behavior. Hello, Evans.io. Welcome back. I think part of the challenge will be that regulator itself has a bunch of runtime behavior. I feel like we should try some of it just so that we know that our integration with regulator is correct. But adequately testing it might be difficult. So let's just try. Let's real quick. Let's look at regulator. Probably have this in my tonic. Regulator. Okay, I do have it in my history. Yay. Okay, so I want to look at maybe what the API is in here that we can make use of. Because if we can go like run a couple requests and then check the capacity of the limiter, that would be good. So let's look at this. No, that's not going to do what we want. We could do this. I know these are not supposed to be publicly available functions, but um, now we could set limit as part of testing. Man, let's look at what regulators tests do. Maybe there's a clue in there. Um, okay, so this is just installing and uninstalling. Now that's something that we should definitely test. So installs a regulator for the client. That's one thing that we should test because that is behavior that we put in here, right? We did, um, we figured out what the name of this regulator should be, and then called regulator install if that one was not registered yet. So that's a good test. Um, Crashing processes are cleaned up. Okay, so this has to do with if you take a token and then you never tell regulator whether the thing you're trying to limit succeeded or failed, um, then it will eventually hit the in flight of 0. Okay, and this is like if you're wrapping it with regulator ask rather than just getting uh, the go ahead and the token. Um, that rethrows errors, callbacks that throw or rethrown. Okay. All right, and this is sort of I've done stuff like this before. This is sort of like a wait until type of thing, but this has a limit on the number of retries. Okay, so that's some one thing. Let's look at no, plug test. Let's see what that does. Limits the number of concurrent plug requests. Okay. So this is more about, so if we, that's a static limit. We're going to be using the dynamic AIMD limit, so that's not going to apply to us. But that is an interesting way to test. Just set a static limit and then um, call it with the con. Yeah. Okay. Um, let's see what's in their support files. Usage. Okay, so this is just kind of a stub, looks like. All right. Well, there's not much there to go on. So I think that maybe what we should do is, since our middleware is really simple, right? We should. So we're going to test that it installs a regulator for the client. Um, let's do kind of a generic test that like increases capacity for successful requests and then decreases capacity for unsuccessful requests. I think that'll probably be sufficient for us. So let's just do this one first. And here what we're going to do is, so we are going to have to make sure we're going to do regulator. We need to uninstall. And this will be test client.regulator, right? Because we need to make sure that that's not there. So if the order of the tests gets mixed up and it's already installed, then this one might fail because it's not, or it shouldn't be installed yet. So let's do bypass.expect once con, and then we'll do something similar like what we did here. Yep. Okay. And where did my regulator test go? There it is. Okay. So now we have a, let's put a line break in there. So let's do assert okay is test client.get localhost bypass.port. Okay, so what we can do now is we can say assert is nil process.where is test client.regulator. So we know that this registered process will not exist. And then after this, we want to say this is a PID. Okay, let's test that. Okay, so that succeeded, and then we have the other two that are not implemented. Cool. Okay, we're gonna do bypass here. Okay, so now what we're going to do is let's look at that that thing where we were able to get the limits. So it was limits, right? So we're going to need to need to make sure that it's installed. So we're going to need to do something like this, but expect. And then we're going to need to do something like this. So we need to make sure it's installed, that it has the eth table, and it has some value in it. And then we're going to do, we're going to let current, say first limit, call it that. And this would be regulator.limits.limit. And we are going to use test client.regulator. And then we're going to do, let's just do 3 of them. And then we'll run the request again, run it 3 times. And then we're going to get the limit, new limit. We'll do this again. Now, this is probably not the best way to test this, partly because these are undocumented APIs. I don't expect them to change, but we're kind of using something that is intended to be used only inside the library. So maybe it's not the greatest thing to do, but this should be good for testing that our integration works when we determine that something is successful. So we know that 200 is successful for sure. We could do something. We could write loops and just test that all of our status codes that we're checking are successful. But that's not really that useful, I think. For this sort of example-based test is probably sufficient to do this. All right, let's test that real quick. Okay, so the limit. So here's the interesting thing. Um, they are the same, and I think they are the same because of what our defaults are. So the initial limit was 20. So we did right. And the min limit starts at 5. So let's look at regulator install, because I think that right again this does a limiter soup with this. So let's look at the limiter soup. I think what happens is that it initializes that module. Um, yeah, so it takes that initial limit. So let's actually test that before. So we're going to manually install it. We are going to install test client.regulator. And we're going to do test client.regulator opts. And we need to delete the, as I think it's going to complain about, delete should regulate. We don't need that being passed to regulator install. Can I unpipe this with the LSP? Oops. Are you gonna give me that option? All right, well, I'll do it manually. Okay, so we're taking the regulator options from there, and now let's do this up here, because we know that the initial limit is 5. What's interesting to me is that it's trying to grow that much. Maybe we should look at what those options mean so that we can choose something that's a bit more reasonable. Okay, and now we don't actually need this line because we can just run some requests, and they all succeed. And yeah. Okay, let's try running that test again. And what's wrong here? Oh right, it needs mod ops, right? Because we're going around your regulator dot limit dot amd. And that should be inside a tuple. Okay. Okay, so what is going on here? Why are they both 20? Let's look at what that does again. Okay, so it does start it with the initial limit. Okay. Right. Okay. Um, so they compute a current limit, based on the maximum of the min limit and the computed limit. So they're basically, it's clamping this computed, what the current limit should be, to the max of, to be between the min and the max limit we set. Okay, so if we hit the max, we reset. This is, yeah, I think I'm wondering if we need to set our regulator ops here, because I think what we need to do is find. Um, so we need to use min limit. Let's use min limit of 1, and let's use max limit of 100, and see if we can get. Excuse me. Um, the other thing is that the latency is probably tiny, and so those computations they're doing for did we hit the latency target or not, are they're probably going, hey, we're well under, so let's jump a lot. Um, let's do keyword merge hardhat dot regulator dot defaults, or hardhat dot defaults regulator ops module. Oops. No, not parens. There we go. Double underscores. And then let's. This is probably not the most ergonomic thing, and I'm looking at this and going. That I would hate to use this. So maybe we need to change how this works, especially this, and maybe it's something where we need to refactor that later, because I would love to set only the options I care about rather than all options, right? And then fall back on the defaults otherwise. So let's try this and see if we get. I don't think that this is going to change anything, and I'm kind of worried that what we're getting here is these two are going to be the same regardless, for an unknown reason. But let's try it. Okay, so they are exactly equal. Let's do assert raises or assert raise, because I think what should happen here is it shouldn't be installed, because if it's already installed, then we have state from previous tests, and we don't want that. And the reason why this would raise would be a bad match, because it's, or something, because it's not going to find the table. The regulator is not installed. Assert raises. Oh, come on. Not having the best day on my keyboard combos here. So let's see, assertions. Assert raise. It's a function. Oh, honestly, so yeah. That does not surprise me. It's not a macro. Okay, assert raise, and it takes a function. And we need to define what thing. Let's just use runtime error and see if that's sufficient. I don't know that it will be. But let's find out. Okay. Yeah, so got argument error. Let's just get around that particular thing. At least we know that it's not installed there because the ets table doesn't exist, right? So calling that that function will cause an exception. Okay, so I am convinced that there is no problem here. We can probably just forget that. What's confusing to me is why our regulator options are being ignored. So let's look at defaults, regulator opts. Let's look at the builder. Maybe we missed something here. No. It's overridable. It's what we're expecting. And then okay, let's do something silly here. Let's do IO inspect test client dot middleware, right? So we can call that to get the stack of what was put in there, and we can see about whether this was actually injected into that middleware stack. It's line 44. Okay, so we've got regulator. Initial limit was 20. Oh, I see. Okay, so the problem was what we want is set to initial limit smaller. Okay, so the problem was that the initial limit was set to 20, and the max limit was set to 20, and we didn't cause anything to back off, so it was always the same, and we didn't submit requests fast enough for it to increase the limit. So so let's set initial limit to 1 and see if that changes our outcome. It succeeded this time. So so we can remove this. Let's see what the new limit is. First limit, new limit, right? And maybe what we need to do is run more of these, or run them in parallel or something, to get it to crank up. What happened there? Did I not save it? I did save it. Why did it not print? Oh, 1 and 1. Huh. Okay, so let's do like 100 requests. I think that's probably interesting. So even with 100 requests, we're getting 1 and 1. What if it's that we need to stub there rather than expect? Shoot, that API is not the same. Okay. let's use stub. This is get slash. I think that's correct. We've done this enough times in the series that I'm pretty sure that's correct. Yeah, okay, so it's interesting here why it worked that first time. And I actually kind of want to delete this. So this is now going to fail. But let's run one request. Right? So we get the initial limit. And then we're not futzing with installing it ourselves. If anyone has ideas on this, let me know. I was actually thinking about I might look at like task async stream, and that way we have concurrency. Because maybe the problem is we're finishing, we're waiting on them. Yeah, let's try async stream, and then we can run, reduce or for each on it. Yeah. Let's do that instead. Okay, so we're never increasing the current concurrency limit here with this loop. It's not sufficient. So let's do task.async stream, and we'll give it 0.100, and the fun, we don't care about the argument. Let's just do test client get, and let's pull this out into a pipeline. So we'll run this async, and then we will do enum for each, enum each result. Actually, let's just do all. Nope, not Rust. Oh, not Rust. I don't have a matches macro. There is something like that though. Match, kernel match. Yeah. No, not keyword match. That's Rust. What are we looking at? Okay, Elixir here. I have it aliased as hex. Let's look in kernel. Special forms? No. Match question mark. I knew there was one. Okay, so we're gonna do matches question mark. Okay, env. One. Okay, so this whole thing we're gonna do assert. So we're gonna do assert. We run, all of them succeed. We're doing that in an async stream. That's incorrect syntax. And yeah. Will you format this better for me, please? Okay, guess not. Let's run mixed format. That's why I won't format. Okay. Okay, now formatted. So we're running 100 requests as fast as we can. We're making sure they all succeed, and then we should get and they're running concurrently with the current test, right? So we should see that this limit does increase. Um, I think just by trying to test this, I got a better understanding of how Regulator works. So this is good. Let's run that test. And compilation error. What have I done? Undefined function matches. Match question mark, not matches. My again, my Rust experience bleeding over here. Okay, so both sides are exactly equal. That's really interesting. All right, async stream. What are we doing here? It returns an enumerable, so sorry. Returns a stream, the given function. Okay. Appended to the given kernel is processed by its own task. The task will be spawned under the given supervisor. We're not using that one. It'll use the default. When streamed, each task will make OK or exit. Right. Right, so this will use... Yeah, fine. We... Is this task.supervisor? Yes, it is. I thought so. Each task will emit OK value. Right, so actually we want to... Um, we could introduce some latency in here, um, because I think that what's happening is this just let's let's just print because I want to see. Let's not use dot. That's too similar to the. Let's use capital R for we did a request. Yeah. Helps if I read the docs instead of just trying to remember them. It's IO right. Yeah. Okay. Because we don't want to print a new line, right? So let's do IO right. Okay. Abort. Okay. Yeah, so there are, I don't know that those are 100 requests. Um, the interesting thing here is that maybe what's happening is we are hitting the limit and then we're backing off. So let's, instead of writing here, let's do, let's do this, and then we can see how the limit changes across that test. Because what I don't want to get us into is a situation where we are not actually testing our integration. We are testing regulator. Um, and if this is too hard, I would just rather err on the side of assuming it works because people have used it in production before. um, but I don't know. It's a difficult situation. So let's see what happens when we just print out what the limit is every time we get the call. So it's always one. So I wonder if what we have here is a problem with. Um, and here's the thing, it didn't print 100 lines here. That's not 100 lines, surely. That's, yeah, that's 66 lines. That's not 100 lines. So, question in my mind is, why did this assertion not fail? And then why is our limit always one? Let's take a quick diversion. Go back over here and look at this. Okay, you must specify a target average latency. This is probably sort of like Little's law related in terms of the average latency. So regulator collects measurements of your service calls and averages them over a sliding window. If the average latency is above the target specified, regulator considers it an error and will begin to multiply decrease. So there's the MD of AIMD. The average latency is below the target and over half the concurrency tokens were utilized. Okay, so it's saying you have to have the latency below the target and have concurrency over half of the tokens. Okay, so probably what's happening is our latency is below the target. So our target average latency is 5 milliseconds. Surely that's enough. Now, so what we could do is probably we can bump this to something big, right? And then the concurrency limit. Okay, so this is the number of ongoing requests. So if we have, I see. So probably what we need to do is set the limit there to be related to the number of schedulers that, so because we're going to run that async task async stream, the number of concurrent tasks it's going to run is related to the number of schedulers. Now we could also tell it, like, let's just give a huge number, right? As far as on the async stream, we could say, number of concurrent, whatever the option is, the number of concurrent tasks should be this. And if that is more than the base limit, then regulator will increase, right? Okay. So this is a lot more subtle than I initially thought. I thought it was going to be like really simple. If it succeeds, you add one. If it fails, you decrease. But it's actually looking for, well, I'm not going to increase the limit unless you're actually using it. So I think that makes sense. And but it does make the figuring out how to test this a lot more complicated. Um, okay, so we set our min limit, our initial limit to 1, right? So um, but the default latency was 5. So let's say the average latency. Let's bump it up. Um, target average latency is the other thing. So let's bump it up to like 500 milliseconds, which is pretty high. Let's try that out, and then if that doesn't work, um, let's try to um, run this with higher concurrency. So run like, I don't know, 30 of these at once or something. So just out of curiosity, what we're going to do here is we're going to do IO inspect system.schedulers online, so that we can get an idea of what the defaults are going to be for task async stream. We could even do something like use this and multiply it by 2 or 3 or something, for our async stream instead of having to hard code it. Okay, let's find out if that changed anything. So it says I have 10 schedulers online. That did not. So we must not be utilizing enough. Now what we could do here, let's try, let's have it sleep for 10 milliseconds. Then it's not returning like so absolutely fast. But it'll still be underneath that 500 milliseconds average latency that we're looking at. Let's try that real quick. Okay, still not increasing the limit. And then let's look at the options for async stream here. Async stream. Options are max concurrency. Okay, max concurrency, let's say 30, and then if we want to do something like use the schedulers online, then we can do that, and that'll probably be a more robust test. Okay, there's still one. I am running out of ideas here, folks. So I have thinking about what we might be able to do here. If this is the iteration, maybe what we can do is put this in here as a query param, and then because I want to see what's going on here, and let's refresh my memory about plug and how it deals with that. plug. Nope. The library plug. Do I not have that installed? I do not. Okay. Plug.con. Okay. Query string is a binary. So those are types. Fetch query params. And then wait, path params? Can you fetch path params? Or is that just set it? Right, okay. Yeah. So what I want to do here is fetch query params con, and then we'll do then it'll be a field. Path, no, not path params, query params, right? What I'm trying to get to here is getting the which request did I get when we're hitting this bypass, right? So okay, let's try that. Maybe I messed something up. Okay, so there's none, then it's 0, then it's 29, and it's jumping all around. But we're definitely not getting 100 requests there. So, and the other thing is, I would expect this. Oh wait, so actually, here's our problem. So if the process doesn't exit, we should get right. So here's our problem. Let's find out what's going on. I'm betting that it's going to fail right there. Yep, it was truthy, got false, right? So we were not testing the right thing here. It's just saying that all of these exited, but we are getting some limiting. I'm guessing what's happening is we've got error unavailable because it hit a limit and then it backed off. So let's remove the max concurrency here and see if we still get that, right? Okay. We can leave those prints in for now. Oh, what did I do wrong? And I keep hitting Command Tab rather than Command J. Sometimes hard for me to remember that I've got. Where's the syntax error? Line 59. Right here. Oh, I don't need the comma because I removed the. Yeah. I removed the options. Okay, expected truthy got false. So, we could do something like, rather than that assert there, let's do um, enum.each assert okay, okay matches result. And this is not so great because I think that it's probably going to terminate the stream when this assertion fails, but let's for argument's sake do this. So we're gonna track which one it was. Not that that matters that much, but okay. And I did that. No, wait. What's wrong? Okay, so oh, okay. That's I did this wrong. So this is okay I result, right? Because that's what task async stream gives us. It gives us either okay or exit. And the other option we could do is put like an assertion in here. Not an assertion. Yeah, I mean we could do an assertion in there. That would give us exits, but let's see here. And actually we want to do this is not sufficient. Assert result. And we'll just rebind result. This is just asserting that the task exited successfully without an exception. Okay. Okay. So we are getting error unavailable. Oops. So okay, I'm just restructuring this a little bit because what I want to see is let's just bind what that one was, and we don't get it here. We just have some funkiness going on with that. That extra okay wrapper is kind of a pain. All right. Okay. So we got on request 1 error unavailable. um, so what's interesting to me here is we are hitting a limit, but it's like we're hitting it because we're going too fast. So let me remove these and let's put in a sleep here. And let's see what happens. Okay, so also on request 1. And actually I want to do IO right R just to see how many of them come out, right? So we get to like 10 requests. No, less than 10. That's like 7 before it blows up. And I wonder if we do 5 here, if we get anything different. Okay, so we got to request 5 before it failed. This is interesting. So if we do 10, what happens then? We get a lot more requests. Okay, I'm a little bit concerned that what we're doing here is futzing with um, something that is too dynamic to test. And let's really quick comment out this line and see what happens. Okay, so here, yeah, it's not even doing that many. But what we're not doing is failing here. They're all succeeding. They're not getting error dropped. But our limit is not increasing. Let's try this. Yeah, and now we're getting error unavailable. So I think that there's probably just too many knobs here to test successfully. Um, and it's very sensitive to initial conditions. So we're saying the initial limit is 10. If we have concurrency that's greater than 10, we run out, right? We have it starts to back off, or it never increases above 10. Let's try times 3. I don't even know if this is reasonable to, and then we don't have a anything keeping those around so they complete too quickly. And this is so fiddly here. Oops. Okay. Yeah, and I'm actually worried what will happen is that we get. I mean, I could put it close to that. See if we tease with. Yeah, uh, I don't know that this is useful, and I think because it's going to be so sensitive to the initial conditions, um, and to the live activity of the system, um, that we are going to get something that is going to be that like the test is not going to run consistently on different machines. It's going to fail on Joe's machine, and it's going to succeed on mine, and it's going to maybe sometimes succeed, maybe sometimes fail in CI, and like that's the recipe for a bad test. Um, so one thing I want to look at real quick before we abandon testing this completely, um, let's look at what it provides for telemetry. What does it do? So what we could do potentially is so it has some events, regulator limit. So these are telemetry events that we can hook into, right? Um, so if this is a new limit, so the limit changes. That's one thing that we could do. We could say, let's run these requests and make sure that we got at least one callback where the limit changed. Um, and we could also these won't apply probably because ask start might not apply because we're not using. Let's just look, see where they're called, because I think we might have a situation where All right, we're doing this. Okay, so it does call telemetry. It says start on ask and gives that, and then it gets the limits, returns the current in flight. Okay. Um, and then it says if in flight is less than limit, then it does it. Otherwise, it's dropped. Okay. Yeah. Um, and when you say okay, it will it will call telemetry stop on ask, right? And if you give error, okay, I think this is probably what we're gonna do, right? So what I'm gonna try to do here is we're gonna make use of those telemetry hooks, um, rather than trying to go, well, what does regulator actually do? Um, we just want to make sure that our and again our integration with it does what it's supposed to, right? So okay, let's dump all of this, right? For now, we might need to reword this test, but we're going to do telemetry attach, and this is increases capacity. We're just make a name on it, and then what we want to do is that's probably attach many, yeah. And what is so it takes a list of event names. And what we want to listen on is regulator ask start and regulator ask stop, and regulator ask exception. And maybe we want to do we're going to, of course, pass self in here because we want to make a function that so it's going to take the event and the measurements and the metadata and the PID, and it's going to just send PID event measurements metadata. And okay, so I've done this so many times when we have things that are concurrent in tests. I've had to do this where you use a telemetry hook. So like, times I've had to test integration with distributed tracing manually. Then and let's do regulator limit again. I think that's what the telemetry hook was. That because then it allows you to just like inject this behavior, and you can receive messages in your test and then test that you got something, like an event actually happened. Okay, so we're going to yep. Okay, so now let's instead of so when we instead of increases capacity, let's say invokes regulator for requests. This is very generic, right? And yeah, we can call this invokes regulator. It doesn't actually really matter what the handler name is. Okay, so we can say assert receive, we should get something that looks like regulator ask start. And then the measurements, there should be no measurements on that, on ask start. Add system time. Okay. But the main thing here we want to get in the metadata is the regulator, right? So we are going to check the, so it's going to pass system time. We don't actually have to put that in there. The metadata will be limiter, was it? Limiter ask start. Oh, measurements is in flight. Regulator. Okay, so let's see. I'm not going to minimize that this time. So we should have in flight, right? And regulator should be test client.regulator. And then we should also receive ask stop because it succeeded. Okay, let's run that. This is probably saner, but we had to try. Oh, and yeah, so I pattern matched that wrong. It doesn't actually have the in-flight in the system time. It has duration on stop, which makes sense. Okay. Let's remove this test that we might not implement. And let's look. Let's see if it changed the limits. I don't know if this will always work, but and then let's look at what the metadata on that is. Okay, so the new limit and the regulator. Now, I think what's going to happen is, because we're only sending one request so far, it's not going to trigger a limit increase. Even if we set all that stuff back to the defaults, which we probably should. So I'm gonna remove the defaults here, the new defaults. That'll simplify our test a lot. And so I'm gonna say refute receive, because I don't expect that it will ever change the limit of this. Now, we could, based on this, make another test that all it does is fires a bunch of requests and makes sure that we get at least one limit change. That seems fairly reasonable to me. We could try that. That may also be, I'm going to put a note here. We sent only one request without any concurrency. So we should not trigger a limit change. Okay. Right. Okay. So let's make a simple function for this. Send to test 4. I think we had to do this in one of the other. Send to test. And we need to put these in the arguments, and then it'll silence that warning. Okay. think it will. Yeah, find module. Okay, we silenced that warning. I think maybe there's some value in seeing if we can trigger the limit to change. That said, with those defaults that we saw earlier, it may not be enough. So let's give it a whirl, and then we can wrap this up and make a commit. Because I think that trying to read the tea leaves too much on whether we're going to trigger a limit change is probably not that useful. Or rather, what that limit will become. And the other thing I was thinking about was that just now was that it's possible that while we were running all of those requests concurrently, and it raised the limit, and then it hit a hard thing and said, I'm going to drop it. We weren't checking the limit in each of those at each of those times that we were running requests concurrently. But we did check it at the end when they had all finished, and it probably backed off. So it backed off to the low limit. So anyway, let's see. Changes limit under concurrency. Changes regulator limit under concurrency. And maybe this is useful, maybe this isn't, but let's find out. And we're going to do some of the same stuff here. Oops. Copy, not cut. Okay. And then we will do so we're going to do, we're not going to care about start, stop, and exception. But what we want to do is we want to see a limit change. On the regulator for our test client. No, it's not where, it's when limit is greater than let's say limit is not equal to the minimum, right? So the minimum is 5, and limit is not equal to 20. So there should be at least one change between 5 and 20, or that's not 5 or 20, right? Say not in 520. Okay. Remember, assert receive expands into a match clause on the receive. So so this guard here is valid in this position. Okay, so now let's do our loop that we had before. And we don't actually care. Async stream. We don't actually care what it is. Let's do just test client get. And then enum dot to list, and we'll just throw it away because we don't actually care. We just want to make sure that it runs concurrently. And then if this fails, we can try futzing with the concurrency again. Um, and I'll put a note here. We just want to make sure that regulator actually adjusts its limits um, occasionally where it's not, where the new limit is not one of the boundary conditions. Boundary values. So the other thing we should throw in here because of the defaults is 200. Although I don't think that in our little test here, especially since we have 100 as our limit, I don't think that we're going to hit 200, right? So I'm going to comment these out because we don't need them. We're only concerned with the limit. One thing that I'm curious about, let's have a look real quick, is whether whether it calls exception when, no, it just says stop result error. Um, okay, so it only uses the exception callback, or the exception telemetry hook in the case of this wrapped sort of ask. But we're not doing that because we want to check the we want to check the result of the Tesla request, right? So we can't use this wrapper version. Yeah. Okay. Yep. Okay. So let's run this test, and just see if we get anything. If it doesn't, then I'm gonna bail on that because it's, yeah, mailbox is empty. Interesting. It doesn't get any limit. Mailbox is empty. So what's interesting to me is this. Here, let's put a tag skip on it real quick. Yeah. Oh man. Oh man. Okay. Um, let's see if you skip this one. Did I clear the shell? What was the original one? Okay. After this not implemented, we got it to pass. Ran it again. So it doesn't get it. I mean, I suppose we could make it wait. This is async false, right? So okay, so there's no way that this is running at the same time. Oh, the other thing is we possibly at the end of our test should detach. Yeah. So not that it should matter, but um, let's just for argument's sake detach handler ID. Is that's just this name? Yeah, because attached does not return anything. It just returns okay or error already exists. Okay. Oh, let's. This may be the problem. Changes regulator limit. And then we'll do the same sort of detach. What was likely the problem was that we were not getting our events because we were adding a handler with the same name. Don't share a state across different tests, folks. Lesson for the wise. Okay, so we're getting something different here. Process is not alive. Where is that happening? Interesting. It's a no proc error from inside regulator. Are we doing something in here? That should cause it to blow up like that. Yeah, that's consistent. Let's look on line 14 of our middleware. See what's going on. Line 14, we're just calling regulator ask. Rather than this, I know we did this last time because I was concerned about poking at regulator without having it installed. I think there might be a way. Yeah. The thing is, we're giving it a name. There's got to be. Probably what's happening here is we've got something where regulator itself has crashed. And just as a sanity check, because this one passed, right? Let's do one of these in the current process and then make sure we aren't doing something weird. Always good to format. Okay. So yeah, now it's no longer crashing. That's odd. I'm wondering if what happened was there was, and this is something that maybe we should consider for stability's sake. If what happened was we're constructing the name here, and then there's a race for calling install. Because install calls the dynamic supervisor to add, to start this child. And then it hasn't started yet. And so here the name is not registered, but this had returned okay, like error already started. Um, and probably what we need to do here is we need a match on this. I wonder if that'll trigger it. But yeah, okay. Well, it's not happening anymore. Probably because. So yeah. So let's remove this because now we aren't installing it. This makes me think that actually we might want something where um, we install the regulator when the connection pool gets um, gets kicked off, because this is like the reason this doesn't happen for fuse is that there is one fuse process. There aren't dynamic child processes in fuse. There's one fuse server process, and it receives all of the commands for installing fuses. And if the thing is already installed, it's just going to like, okay, somebody else got here first. And so it's actually safe to keep calling it. What Yeah, so let's see if we trigger this again if we remove that initial one. uh yeah, we're getting that. What we're not getting is yeah, honestly, this is a problem. This is a problem. So I think to mitigate this race condition, we're gonna have to do something like the options here are the same as dynamic supervisor on start child. It's going to be okay PID, okay PID term, error already started PID. Um, Ignore. Yeah. Okay. So if we get okay PID, we don't care. Okay. If we get okay PID info return, we don't care. Um, the other options are ignore or error. Okay, so I didn't think we would have to deal with this, but anything else? Um, Okay, so here's the thing: is I think if it's error already started, that's okay too, because it should already have registered its name. And anything else, we should raise, like, let's just say raise condition in regulator.install. Um, I don't I don't know that this is going to be the problem, but I would expect that what's happening here is where is a guard biff? I don't think so. Yeah. I'm not sure that that's guard safe. Because what I would love to do here is put when PID equals process, where is reg name. Um, I Yeah, it's probably gonna say that's not guard safe. Yep. Okay. This is getting to be nasty code. To deal with this race condition. And here we'll do the same raise. This is just a temporary thing to see. I'm not going to keep this in the code, I don't think. Um, Probably need a better way to ensure that the regulator is installed already. You know, one possibility is that we never pass, except for maybe should regulate, or we ignore all the other options up here, right? Um, and that we set those up on startup. Um, uh, Not, we'll say not registered, and here we're gonna do other, and we'll do inspect other. I know this is really dirty, and I will not keep this. Absolutely will not. Um, and here we'll say else. Oops. Else, come on. Else, okay. That way we're always returning okay or raising. Now the other thing that we could do here, yeah. So let's start with that, and let's see what happens um, in our test. And I think that let's do one thing here, because I think what I want to do is filter. Um, or exit. Is there a filter map on enum? Or just filter? We can use stream filter. Let's use stream filter. So if it matches exit, and let's condense this to an inline capture, and then we'll stream map da, 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 lm. I never remember this one in Elixir or in Erlang, honestly. Get the element of a tuple. Tuple. Nope. Freaking Rust getting in our way. LM. There it is. Kernel LM. That's the one I wanted. I don't know. Okay. LM1 is what we want. Because we want the second one. And let's do enum to list. And then we're going to do IO inspect results. So we should get from this only the ones that failed, right? So if they exited, you know, if they bombed, then we'll get whatever their error was. Cool. Now, what may happen is that this links to yeah. Let's just find out. Okay, well, there were no errors. So either we handled this race condition, or oh wow, this is ugly code. So yeah, so we either handled this race condition or it was never triggered. So I'm tempted to do this, and we're just going to comment out this code and see if we can trigger it one more time. Because if we can avoid adding additional machinery for this thing, that would be really good. Oh, well, that's the problem. I actually didn't trigger it. Here, let's restore this. I didn't trigger it because we did that one time thing, right? So if I remove the one time thing, then we should trigger it. Yeah, okay. So what do we get? Yeah, it doesn't have the monitor. It's actually a race on the other process. Not this, but the monitor process. So let's look at limiter soup and see what it spawns. It's spawning that in limit calculator. Okay, so wild. So I would expect that creating this limiter that you would not get the registered name until init returned. But what's happening is this is not returned yet. So this child has not started yet, but the process is already registered. And that's the race condition we're hitting. I mean, because it's looking for this. Right, we're calling regulator ask, so we've already gotten past the part where it thinks that the thing is ready. And regulator, so oops, in lib regulator.ex, if we call ask, it does this, and it says monitor me name, right? And that's so that the limiter can, excuse me, sorry, the limiter can track tokens that were dropped by processes that exited unexpectedly. So that's reasonable. But if this monitor has not started before we call ask, maybe I'm trying to play too wild and loose here. Maybe what we do is let's forget this, because that's not a sufficient check, obviously. Um, the other thing that we could do is check for the child. This is like, it's going to couple us too much to how this is put together. But like, look at the limiter soup and check for the existence of this monitor child. Let's look in here. Yeah, see, like it just concats the name with monitor there. Um, and then it also spawns a limit calculator. Okay. And there's no like wait for this all to be started up. So what I'm tempted to do is like, let's leave this case in here for now. And then I'm tempted to just call regulator install each time and then ignore the result because we should get error already started. We are gated by calling into that dynamic supervisor on every request, which I don't really care for. I think that's kind of bad. But since we were doing that with Fuse, is it? I don't know. On the other hand, let's look at what Tesla middleware Fuse does. Here we go. What it does is it asks first, and then if it gets error not found, then it calls install. But Fuse install, again, goes through one process, not this dynamic supervisor thing. Which I wonder about, could we do the same thing? Let's look real quick. So if we ask, and ask call, no, because this is going to hit the same, no proc, right? And I don't think that we can reasonably check for that kind of exception. Now we could submit a patch to Regulator that says, hey, if this monitor me, yeah, we could update monitor me to go, hey, not installed. This would change the semantics of ask. We would change the return type of ask. might make this like a with or something. The other thing that you could do too is limits might have to return something similar, might have to check. All of these functions here would have to check whether the thing that's being asked for is present. Okay. I didn't expect to hit this race condition, but let's start with this. See if we get any exceptions. Um, and then if we get any exceptions to like from race from this, then we can think about whether we want to just blindly call regulator install. Also, do not send me promotional things on my channel. Please go away. Okay. So let's make sure that we didn't change our test in a way that I thought we were doing. Okay. So this might actually be the solution. Now, we're not getting the limit change, obviously. It's okay. But we are learning that maybe it's just best to call regulator install. And for dialyzer's sake, we'll do, because it's expecting different types there. I don't like it. It's not great. But it may be what we need to do. Yep. Okay. So, at the very least, one thing that I'm curious about. Let's look at dynamic supervisor. Let's just read the code, because I'm wondering if what happens is if it's already starting a child and you are trying to call start child again on it with the same identifier, will and it so it should return error already started, right? I'm wondering if that means that it will wait until that child has started before it returns you error already started. And what's possible here is that yes, that is the case, and so that's the proper way to avoid our race condition. And it's maybe just that it when you call start child, it waits to process that, and everything else is backed up in its message box. Like, it doesn't do that and then like start processing other things. It just blocks on starting that child. If that's the case, then this is the safe way to do it. Okay, so let's find start child. We don't care about start link. Start link, start child. Okay. So call validate. Okay, call. So gen server call to supervisor start child. Okay. That's probably not exactly a gen server call, but let's find its handle call. Yeah, it's just validating the argument. And terminate, and which children, and count children. Okay. Okay. So traps exits. Okay, and we don't know what init state flags is. Okay. Mod. Okay, so there's a struct defined in this module. Okay. Handle call. Which children? Nope. Count children. We don't care. Terminate child. start child. Okay. So this is just about limiting. This is the children. Okay, so this is a map from the child identifier to the children, right? So let's look at handle start child. Okay. So then it internally calls start child. Right. So if this is, this is calling start link on that child, probably start link, which will block until that thing has completely started. Um, so okay. So if there's any other, yeah, this is all like direct reply. It's blocking while it's handling the start child message. Okay. Right, and then save child. It's the MFA for restart. State children PID. Um, I wonder if there's a. No, handle cast exit. Okay. Nope. So let's look at gen server because I think, or supervisor even. Um, yeah. So if you have that name already registered, that's why this would get error already started. Um, so let's look at start link. So I'm pretty sure that this is why you get that error already started, right? Do start, yeah, gen start. So it's probably gen start. Um, gen server link local name, right? Okay. Yep. So whatever the Erlang gen module, which is not documented by the way, and we would have to look up. Okay, so I think this is safe. Um, it's not ideal. I would rather not have to call this on every time. I'd rather have it started when we start our client. Um, but if we do that, which may not be a bad idea, um, if we do that, then what we will need to do is rather than the um, I'll put this down as a to do for next time. Rather than having the child spec that gets generated here only start Finch, we will need to have a supervisor module um, and give that supervisor module the arguments it needs to start both Finch and a one-off task that installs the regulator. And that way, you know, unfortunately, we can't just tweak that sort of thing at runtime. Um, it's persistent state. It has to stay up. Um, so we're not going to be able to have it change. Like you couldn't log into the IEX shell on your live app and change the state of that regulator. That would actually be bad. Um, so maybe that's a reasonable thing to do next time. I realize we're over time. We didn't do any Rust this time, um, and but let's leave that be. I think that it's probably um, let's for one more test. I'm glad we learned this. Let's remove that guard and see if we get any limit changes, and then we can move on. Yeah, we didn't get any. So I don't know how valuable that is. Let's let's just delete this test, because I don't think that it's that useful. We really only care about, do we invoke the regulator from our client. What regulator's behavior is kind of outside um, outside this. Okay, so and actually let's put this back in here and let's make a receive on that. We never call regulator ask with a function. We are always taking the token to handle ourselves. So we will never get exception events. The other thing that we can do here is we can add this. I noticed this in the invocation of the telemetry that if it succeeds, if you call the OK function, it says result OK. Now, what we might be able to do is, and we don't actually care what the measures are. Okay, so we'll never get those. Maybe what we do is we add a test that shows result was not okay when we have an error for the should regulate, right? That's probably a good thing to do. So let's copy pasta this and then we'll clean it up. Okay, so regulator errors. Records errors based on should regulate. Okay. I could probably name these as using the PID of the current test. That might be smart. Okay, so here what we're going to do is right. So we should get this, and we should get a result when result not equal okay. We should get it invoking that with this. So let's give a condition where we might trigger this. So we could say, let's give a 503 here. Bad upstream, something like that, just for fun. So we're expecting a 503 response from get, and this will be something that our should regulate will say this is an error that we should cause to back off. So we should receive let's make this fail first. I think that's more interesting. So let's say okay. And then it'll be like, hey, I never got anything for that. But here's what else was in my mailbox, right? So, okay. Let's run this test. Okay, so no, there's nothing matching. Okay, we got um, ask stop duration result was error, right? We got an ask start. Yep. Okay. So, so let's say we want to make sure that we got an error recorded. Okay. Um, yeah. Now the other thing I forgot about is this is inside retries. That's why we had so many messages here, because it was asking the regulator multiple times. That may have been a factor in our and why we were failing so much more than we expected. We probably could have set the retry ops to have no retries. So maybe that's something we can do in the future. So, okay, records errors based on should regulate one. Yep. Okay. Um, let's. I think we're finally at the point where we can make a commit. Um, I'm not 100% happy with that that test. I wish we'd been able to do more that shows the rate limiting, basically, the concurrency limiting that that regulator does. But I also think that it's not valuable to dwell on it too much, um, and and then have to worry about um, have to worry about figuring out what the right set of parameters are. So let's make that commit. Okay, let's look at the diff. Those things are unchanged from last time. Right. Okay, so the macro was unchanged. Um, we had the unchanged options from last time. And we added regulator. And it doesn't show our new files. So let's add all and look at the diff, the full diff. Okay, cool. Okay, so here's our middleware. Right, so we call install to make sure that it exists. And yep. Now we could do like this to try catch, um, rather than regulator install on each pass. That might be okay. But what we'll be doing is catching no proc, which is not the greatest thing to try to catch. You know, let's take a little bit less than 10 minutes and do that. Okay, so we're gonna change this to try, and these have become else clauses, right? And we need to catch, and let's look real quick at what the syntax is for that. Special form. Okay, so we're not going to rescue. We'll catch. Um, Let's see if they're... No, that doesn't tell us anything. So it would be catch, exit, no proc, right? Right, so you can do bad arg, no proc. Let's see. No proc. Process. Let's see if there's an exception. No. Let's see what the built-in exceptions are. This might just be Erlang error. We have to catch no proc. But I'd rather use a real exception if we can. Runtime error is not good. Yeah, it's not bad arg. I think it's just exit no proc. And then anything else will be re-raised automatically. So, yeah. Yeah, okay. So, exit no proc. Then we'll do our regulator install here. And call. We have to put this back in so that it's there. Oh, I forgot. You don't concat that way. You put it on the front. Except that's not right. Okay. Let's undo that. There. That way when we come back around. So we're basically just we're basically just going to call the top again. That way we're tail recursing. So we're like, if it exits with there is one of these processes doesn't exist yet. So the monitor or something like that, then let's do that. Okay, so I'm going to put a note in here for myself. If the regulator isn't installed yet, this will raise no proc, right? On the child monitor process, or for the child monitor process. It isn't sufficient to check for the existence of the supervisor that starts the monitor. Because it may be registered, but its children may not be started yet. However, we want to avoid calling regulator .install on every invocation. So ask is wrapped in a try catch. Okay, that's a really long way to say what we learned today. Um, and just for sanity's sake, let's run our tests again. Interesting. So I would think that that would, well, but I guess it can't catch exits. Boo. Boo. Okay. Unfortunately, we have to back that out. That's a shame. Okay. I'm going to keep this comment, but this is just this is the kind of race you would not see in another language other than Elixir or Lang. This is a, well, you know, it takes a while to start up that process, and maybe it's not fast enough for you. So and I should have remembered we can't trap exits there, or we can't catch exits unless we're already trapping exits for the process, and I don't want to make that decision for the user. So um, now we could do something like wrap this in a task where we yeah, it just seems too complicated. Okay, so let's put that back. So we're going to put this back above, right? So we're going to always call install, and we're going to remove this, and this is going to go back to case. Okay. If the regulator is installed yet, ask will raise no, will exit no proc for the looking for the child monitor process. That we are blocked on the supervisor start child call. If the limiter, let's use limiter here because that's what we're doing. If the limiter is already installed, this will return error already started PID. And I don't need note and race. We'll just put race. Okay, and I'm not going to reflow that because Z doesn't have. This is one thing from Emacs. one of the things from Emacs that I loved was I could hit meta q and it would reflow a paragraph inside a comment. It was brilliant. And then I would always get consistent line lengths, but the mix formatter does not have, it doesn't reformat comments for good reasons. Let's run all tests just to be sure. And then let's call it a day. Thank you everybody who's still on for following along with me and living through this pain with me. Okay. Let's look at the diff one more time. Okay, so we have a strategy that you can set. Yep. Okay, and then we check that, and there's our default options, and our default, and then we have the regulator middleware, and we got the tests. Okay. So add regulator middleware. What a journey. What a journey. Okay. This is a great place to stop. I'm half hour over what I wanted to do. But thank you all for sticking this out with me. And we will see you next time. And maybe next time we'll actually get to the Rust code that I wanted to get to today. But we had a lot of work to figure out why regulator wasn't doing what we wanted to do. And you know, making sure that we had the right pattern there, kind of figuring out some weird things with race conditions in Erlang and Elixir. And yeah, thanks for sticking that with me, and we'll see you next time, hopefully next week. Have a good weekend.